In this video, we'll solve a problems on properties of fluids. Okay, there are so many properties. For example, you have the density, specific weight, shear stress, shear strain, specific volume. So many properties are there. So related to some properties, we'll solve problem here. Especially this problem is mainly related to the dynamic viscosity, shear stress and shear strain. Okay, we have the relation between these three and we'll try to solve a problem related to these three data here. Okay, first of all, I'll read the problem here. If the velocity distribution over the plate is given by u equal to 2 by 3 y minus y square, he is given the velocity distribution over the plate, in which u is the velocity in meters per second. He is given u is the velocity in meters per second, that is u. What about y here? Y is the distance over the plate, above the plate. For example, if you have the plate here, this is the plate, and whatever the y-axis, this will be the y-axis here. Okay, this is the y distribution. This is the distance over the plate. If you see this one as a plate, y is the distance above the plate, and u is the velocity in the of the plate, and he is the given the relation between u and y, right? It means you will get some one of the graph here, and what the graph shows, u equal to 2 by 3 of y minus y square. He is given like that. Okay, this is the relation between u and y he is given here. Okay, so you have to determine the shear stress. You have to find out the shear stress at y equal to 0. When y is 0, what will be the shear stress? Shear stress is denoted by tau. Okay, and when y equal to 0.15, for example, when y equal to 0.15 meter, what will be the shear stress? Okay, so you have to find out these two shear stresses. This is the problem he is given. First, we'll try to write the data one by one here, and we'll try to solve a problem related to this data here. Okay, data. Okay, what he is given here? The velocity distribution. First, velocity distribution he is given. Velocity distribution. What he is given? U equal to 2 by 3 y minus y square. This is velocity distribution. U is, what is the U is velocity in meters per second, and y is distance. Y is distance in meters. He is given here. Okay, above the plate. Determine the shear stress at y equal to 0. You have to find out shear stress at y equal to 0 is how much. You have to find out. And shear stress at y equal to 0.15 meter above the plate is how much. You have to calculate. Take dynamic viscosity. He is given dynamic viscosity of the fluid. You have the notation for viscosity. Dynamic viscosity is mu. Mu is he is given 8.63 poises. Okay. Normally the unit of the viscosity is poise or Newton second per meter. These two are the units. But we want here meter, Newton second per meter. Why? Because this velocity is meter and second, everything is there. So we want to convert. Okay. How will convert? So 1 poise is, normally the standard, the value is 1 poise equal to 1 by 10 of Newton second per meter. This is the normal conversion. Therefore, convert the 8.63 in Newton second per meter. How will convert? Therefore, mu equal to 8.63 divided by 10 Newton second per meter, right? If you simplify, 0.863 Newton second per meter. This is the unit of the viscosity. Okay, now solution. We'll go for the solution here. So to find out the shear stress at y equal to 0 and to find out the shear stress at y equal to 0.15, we'll start with the formula here. The normal formula for viscosity will start. Mu equal to the dynamic viscosity, the formula is shear stress divided by shear strain. This is the shear stress divided by shear strain. Okay. Okay. Shear stress, the notation is tau, divided by shear strain is change in velocity divided by change in distance. Okay, this is the general formula. If you simplify tau divided by change in velocity, velocity is u, right? Change in velocity is du, divided by distance is y, change in distance is dy. This is mu. But what we want to find out, tau, we need the tau here. Therefore tau equal to mu into du by dy, du by dy. This is general formula for the shear stress in terms of shear strain. But what we want to know, the shear stress at y equal to 0 we have to calculate, right? This will be equal to mu into du by dy at y equal to 0, right? At y equal to 0 we have to find out this will be how much. This is equation number 1, we have to take one. Similarly, shear stress at y equal to 0.15 equal to mu into du by dy at y equal to 0.15 equal to how much? That is second one. Okay, now we'll start with the given equation. What the given equation? We know he is given the equation u equal to, because we want du by dy, mu already is given, so u equal to what is given, 2 by 3 y minus y square, he is given already, right? So from this one we can derive the just derivative, that is du by dy. Make the du by dy equal to 2 by 3 minus 2 into y. This is du by dy. Okay, now du by dy I want at dy at y equal to 0, right? First one, when the distance is 0. Okay, substitute y equal to 0 in this equation. That is 2 by 3 minus 2 into 0. That will be equal to 2 by 3. So then you will get the 0.667. This is du by dy at y equal to 0. Next, what we want one more, du by dy at y equal to distance is 0.15. We have to calculate, right? When the distance from the plate is 0.15. That is 2 by 3 minus 2 into 0.15. If you simplify this one, we will get that 0.367. Okay, now go for equation 1. Where is equation 1? To calculate the shear stress at y equal to 0. Therefore equation 1 becomes tau shear stress at y equal to 0 equal to mu into du by dy at y equal to 0, right? At y equal to 0. Now what is the viscosity here? Dynamic viscosity already the given data in terms of Newton second per meter square, already it is there, 0.863 is given. 863 multiply by du by dy at y equal to 0 is how much? It is here. We'll go back, just wait. Okay, just 0.667. This will be equal to, if you simplify, you will get 0.5756 Newton per meter square. Normally the shear stress, the unit is Newton per meter square. Y equal to 0. This is 1. We have calculated already, right? Now find out the shear stress at y equal to 0.15. Equation 2. Substitute in equation 2. This will be equal to, mu is how much? First we'll write the formula, mu into du by dy when y equal to 0.15. Okay, this will be equal to, already we know that mu value is 0.863 multiply by du by dy at y equal to 0.15 is already we calculated, 0.367. Simplify this one, and after simplification we will get that 0.3167. We will get here. Okay, what is the unit? Newton per meter square. This is shear stress at y equal to, shear stress at y equal to 0.15. This is how we have to calculate the shear stresses at different y distances according to the given data here. Okay.